Hello geometry students, today we are going to learn about volumes of prisms and cylinders. This is on page number 334 to 337 from Big Idea Geometry Student Journal. And basically in this chapter we are going to learn definition of prisms and cylinders, then volumes of prisms and cylinders, and similar solids. So let's move to our lesson. So very first thing, before jumping to learn about the volume of prisms and cylinder, let's first learn about what is prism. Prism is basically, that's what a three-dimensional shape, and it has two identical shapes facing each other. All right, maybe top and bottom, you can say that way. These identical shapes are called bases. All right, they're identical. Keep in mind though that those shapes are going to be identical. Now next thing is about the bases can be of different shapes. It could be triangle, it could be square, rectangle, or any other polygon. All right, so base, if it is triangle, it will become a triangular prism. If it is a square, it will become square prism, rectangular prism, or heptagonal, pentagonal, whatever the base is. Other faces of a prisms are, they can be parallelograms or rectangles here. All right, so let's move to the next page and see how they look like. This is an example of triangular prism. You can see the the top base. They're saying that here, when you look at the bases in this case, this is the base, one base is here, and this is the base, and it's the other base. So we can say these are two top and bottom part, so they're identical. These two are identical, they have to be identical, facing each other. So that's why that's a prism, and it's a prism kind of structure. So cross section is a triangle. Let's move to another kind of prism. So here you see, it's, if it is, the bases are here, you see this one, this is the base, and this is the base, other base. So let me use other colors. So that's the base and that's the base. These two are identical and they're facing each other. So they're facing each other, it means they are, if that's the shape of square, and all the height, length and width, everything is same, and that becomes a cube. What if the base is just a square but it's not a cube, means the height is not same, it becomes a square prism. If the base is a rectangle, then it becomes a rectangular prism. All right, so let's move to the next page. And there is another kind of prism, is called oblique prism. Oblique is kind of, it's little bit tilted. All right, it's not standing straight, it is little bit let me fix this here, that's tilted. All right, so tilted means it's not standing straight. So that's the base, we see it's a triangle, that's the another base, that's, they are facing each other, so it's a triangular prism. So if we have to name it, we say it's a triangular prism. And then the top and base there, but they're not just above of each other, it's little bit tilted, so that's a oblique. But we never take this as a height, this is not taken as a height. Height is supposed to be this perpendicular distance, is this one. All right, this perpendicular distance is the height. Always keep in mind, this is not the height. Let's move to another figure. Then we talk about cylinder. Cylinder. So what is cylinder? Cylinder is a solid object with two identical flat ends. that are circular or elliptical. So basically here you're going to learn about circular one. So there in prism you saw the shapes were, the bases were different: square, rectangle, triangle, could be anything. But if you see that the bases are circular and one curved side, so you see the sides are not flattened, they're curved, and this is called cylinder. So wherever you just take a cross section, anytime you take the cross section, that's going to turn circle every time you take a cross section. So this is an example of cylinder. In that case, you just need to know two things about cylinder. One thing is you're supposed to know the radius of the cylinder. It's the radius of the circular base, and the height is basically the perpendicular distance, this height of the cylinder. Let's move to the next information. So here for next information we have same way, the way we had right prism or right or oblique prism, we have right circular cylinder and we have oblique circular cylinder. So here right cylinder, when it has a base circle and it's aligned directly above it. All right, so actually these two definitions almost same thing here. So we have the same definition. So here right circular cylinder we talk about is basically cylinder where the centers are aligned on the top of each other, right cylinder, and right circular cylinder when the base is circular. So it's a differentiation, but you may have elliptical or something, but we're not going to go much in detail. Basically we're going to learn about this kind of in this chapter. So that's a right circular cylinder. You can see the center is here, other center is here, so they are aligned on the top of each other, and the base is also a circle. So that's a right circular cylinder. Now other one is, what if it is not a right one, it's an oblique one, little bit tilted. In that case you will see it's a tilted one. You can see they are not aligned directly on above each other, the centers. So in that case a center is here and this top center is here. They're not aligned, they're tilted, but our height will be always the perpendicular one. This one we are considering height, and r will stay the same way. R is this one and this is the height. Keep in mind, when it's an oblique, it's always the perpendicular distance from top to bottom. So let's move to another information. Let's learn about volume of prisms, how to find the volume of prism. Even for cylinder also there is just one basic formula for any prism or cylinder, that volume is base area time height. So B is the base here, base area, B is the base area, and H is the height. So you're supposed to know the base, what shape the base is. As I told you, prism can be different shapes. The bases, it could be a triangular prism, it could be a square prism, it could be a rectangular prism, or it could be any other shape like pentagonal, hexagonal prism. Depending on what shape is the base, and the top means the base is top and bottom are the bases. Whatever this identical shapes are, you name it accordingly. So you need to know how to find the base area here. All right, so you need to know if it is triangle. Let me review once more with you. If it is a triangle, so triangle could be like this, where you have base and height here, base and height, or it could be a triangle like this, where you have this is base and this is height. Okay, so in that case your triangle's area is base times height over 2. All right, now what if it is a square? So that's very easy. Square means all sides are congruent here, and it has 90 degree at the angles are 90 degree like this. So our area would be side square. What if it is a rectangle? So in that case we have length and width, all angles are 90 but to different sides. So area will be length times width. What if it is a polygon? It's a pentagon, hexagon, heptagon, and so on. So in the last chapter we learned about that's basically apothem times perimeter over 2 that you have to use, or sometimes you may need to use the trigonometry to find apothem or perimeter depending on what is given. All right, so let's move to the next part. If we have to find the volume of the cylinder, here we talk about if we have to find the volume of cylinder, again keep in mind, as I told you, the formula is same. Volume is actually base area times height, the same way it was in prisms. Only the difference, because here the base is circular, so your area of the base is going to be a area of a circle. So if we're supposed to do that, so you can see your base is here, that's a circular. Here you can see that's a circular base. Top and bottom are identical shapes, and this is the right one, this is the right cylinder, and that's a oblique one because it's tilted one. You can see the centers are not aligned on top of each other. So but the bases are circle, and you need to know the circles area that you already did in your previous sections. If your circle is like this and you know the center is here and you know the radius, so what's the, if this is the radius and you're supposed to find the area of this circle, the area is supposed to be what? A is pi r square. Keep in mind, never, so that's why this is replaced here, pi r square. The b got replaced by pi r square, and then h is the height of the cylinder. So you're supposed to use that, okay? And just never use 3.14 for pi, that's approximated value. If you're using calculator, always use the pi button. Let's and one more thing, you have to be very careful. If it is an oblique cylinder, this is going to be the height. You never take this length as a height, okay? Keep in mind. And in that case your r is only this much, that's your height, r. Let's move to the another information. Now we have to talk about similar solids here. What are the similar solids? So similar solids are basically here, similar solids like it's just like a similar figures. What happens, one is the dilation of other, like if we talk about 2D figures. So same way in 3D, it's just like one gets bigger in each and every aspect, means every dimension gets bigger or smaller with the same fixed ratio. So two solids of the same type with equal ratios of corresponding linear measures such as heights, radii, and it's any kind of dimension. If it gets bigger, smaller with the same ratio, they call similar solids. And if you know that the ratio, what's the ratio? That is called scale factor. You call it a scale factor. And also if you're comparing their volumes, so the volumes will be the comparison of volumes, the ratio would be k cubed. All right, so if you have, like, there is an example here given for cylinder A and cylinder B. You see cylinder A and cylinder B, one is smaller, this one is smaller, and this one is bigger. And when we carefully look at the dimension, the linear measures, we see this is 3 centimeter is the r. Now it is 6 centimeters. So how many times it is? It is 2. 3 times 2 is 6. Now if I know this is the same way and they're going to be similar, and their heights in this case, like if I know they're similar solids, and suppose if it is 7 and this is 14, just imagine 7 centimeter, 14 centimeter. If we are finding the and if I say they're similar, then if I say, okay, volume of the smaller cylinder is 45 pi centimeter cube, we have to find out what's the volume of this cylinder. So we have to know the ratio of their corresponding linear measures. So this 6 and 3. So if we have to find this one, so if we can say volume of A over volume of B, that is what we can just compare that. So in that case, if I say we have to have the scale factor, but yes, keep in mind we have to get the scale factors. So in that case, the linear measure, we have to keep it here 3 and this is 6. All right, that's a scale factor times cube. So let's plug it in. What's your VA? That's 45 pi, and VB, we don't know how much is VB, and then that's what 1 over 2 cubed, and that's going to be VB is, when you solve it, this part is going to be 1 over 8, and you cross multiply, so 8 times 45 pi, that's 360 pi. So that's one way. So this is kind of little complicated here. You can make it a little easier if you know the VB is bigger. So when you take the scale factor, you just take that one easier. So VB over VA, you can do that way also. So measurement from B will be on top. If the bigger one you keep on top, so your calculation is easier, and that is your K, so K cube. So in that case, K is your, it depends on how you take it. So it could be how you write your expression. If you solve it, in that case also VB is 360 pi. That can be written that way also. That's easier, I feel so. Then another thing you have to do is the Capillary Principle. Capillary Principle, it talks about that if cylinder with height h and base radius r and rectangular prism with the same height and the same square base with side of length r root pi. All right, if you see that they have the same height with the height h, all right, there is a cylinder, you see there is a height h. Let me just make it again. If you see a cylinder is here, the height is given h, all right, and its base is how much? The base is r. And there is another rectangular prism with same height. Means if you're just thinking about the height of this cylinder, this is also h, but the square base with side of length r root pi. So if you're just seeing that's a base, this is a rectangular prism, and actually it's a square prism. So if it is r root pi, then they, and also they have the same cross-sectional area pi r square at each level. It means if I'm just finding this area, what is the area of this thing? Because it's a square, so area is pi, that side is square, so r root pi square, that's area, and that's going to be what? Pi r square. So the cross-sectional area, this is going to be this. And same way, if you're finding cross-sectional area of this part, that's also, because that's r, that's going to be pi r square. If you see cross-sectional area is same at every level, no matter where you find the cross-section, it's always same, then by Capillary Principle, the prism and cylinder, they have the same volume. All right, so they are going to have the same volume. So base area is pi r square h, and here also base area times height is pi r square h for cylinder and prism. All right, so that's all for today's lesson, and I would be doing problems in the next chapter section, the volume of prisms and cylinder, in our next section. Till then, stay safe and thank you.